1.6 is complex numbers, and that's what we're going to be talking about. And just to introduce that, so if I gave you or asked you what the square root of 9 was, then you should be thinking, what number do I multiply by itself to get 9? Alright, well, we know that we can multiply 3 by itself and get 9, so the square root of 9 is 3. And this is the principal square root. This is the positive square root. I also know that if I multiply negative 3 times negative 3, I get 9 as well. So if I were working in an equation and I were looking for the solutions and I introduced a square root, then the square root of 9 would be positive or negative 3. Alright, and I don't want to get real off track here, but the problem arises if I give you something like this and say, what's the square root of negative 9? And you should intuitively be thinking, I can't multiply a number by itself and get a negative number, because a negative times a negative is a positive times a positive is a positive. So there's nothing that I can multiply by itself and get negative 9. Well, this is where this whole new number set comes in. So by definition, I is going to equal the square root of negative 1, which if I square that, that means I squared is going to equal negative 1. Alright, so this is going to be important that you remember that, those two values, the definition of I and I squared. Alright, so going back up here, if I just apply my quotient rule here, actually if I apply my product rule and then my quotient rule, so my product rule tells me that I can multiply two factors underneath the square root. Well, that gives me my negative 9, and then my quotient rule tells me I can split that up. Alright, so this is just like the square root of negative 1 times the square root of 9. Well, we all know what the square root of 9 is, that's 3. And now, by definition, you know that the square root of negative 1 is I. So really, the square root of negative 9 is going to equal 3i. Alright, so this, like I said, introduces a whole other set of numbers. We call these numbers complex numbers. And we usually write complex numbers in the form a plus bi, where a is the real part and b is the imaginary part. Alright, so if I give you a complex number that looks like this, negative 6 plus 4i, for example, alright, and said, what is the real part? The real part is negative 6. The imaginary part is that positive 4. Don't include the I when I ask for the imaginary part. It's just the number in front. So it's the 4. Alright. Now, these problems are coming from 1.6. If I give you something like this and ask you what the real and the imaginary part are, that's one you just maybe think, okay, what's going on here? Is this in the form a plus bi? Well, no, it's not. But you know, if you've got more than one term and you've dividing by one term, a monomial, you can just split that up. So I would split that up as to 4 over 2 plus 7i over 2, or 2 plus 7 over 2i. Now, this is in the form a plus bi, where a is my real part and 7 over 2 is my imaginary part. So 2 is my real, 7 over 2 is the imaginary part. Alright, and then the good thing after that is you pretty much treat I just like you would any variable, unless you come across I squared or something that you can simplify. Alright, so if I'm looking at number 18 from 1-6, I'm thinking, alright, I'm going to treat just like I would if that were an x, which means I'm going to get rid of this parentheses. I'm going to get rid of the parentheses by distributing that negative, and then I'm going to combine my like terms. So in this case, I've got 3i plus 3i, which is 6i, and then I've got that negative 2. And I'm going to write it out like that, and then say, okay, if it asks for a plus bi form, this is not a plus bi form. It technically is, but you want to write it like this. And then the real part is negative 2, the imaginary part is 6. Okay, I'm going to keep going here. Alright, now let's do number 30. Alright, if I've got two factors, So I'm looking for the product here. I'm multiplying here. I'm going to treat this just like I would any other time I was multiplying 2 terms times 2 terms, and I'm just going to FOIL this out or distribute it however you think of that. So when I do my first, I get 5. When I do outside, I get 5i. When I do inside, I get negative 3i. And then last, I get negative 3i squared. Alright, and this is no big deal except for the fact that anytime you end up with an I squared, you're going to substitute in what I told you by definition I squared is. I squared is negative 1. So you're going to substitute that in. You're never going to leave I squared in your answer. Alright, so combining my like terms here, I've got 5 plus 2i, and then a negative 3 times a negative 1, which is a positive 3. So this is all going to simplify to 8 plus 2i. Okay. Alright, I want to work 34 even though it's still just a product. But I want to show you what happens here when I multiply these two factors. Alright, so if I do my FOIL thing and I do 9, and then I do outside, I get positive 21i. Inside, I get negative 21i. And then last, I get negative 49i squared. Alright, look what's going on here. Those are opposites. Those are going to add out. And then here, when I substitute my negative 1 in, I get 9 plus 49, which is just positive 58. Now, the reason I did this was not to make sure you had more practice foiling, because I think you've got that under control by now. What I'm trying to show you is that I started off with a complex number and I ended up with a real number. Alright, and if you notice the relationship between these two factors, they're basically the same except the sign in the middle changed. Alright, that sign in the middle, if the only thing different is the sign in the middle, when I FOIL that out, this O and this I thing, they're always going to be opposites, and they're always going to add out. Now, why am I telling you all this? Because we're going to use this in order to divide. Alright, so these are actually called conjugates, complex conjugates, because they are the same terms, but the sign in the middle is different. Alright, so if I bring in 38, for example, and I'm looking at 1 over 1 plus I. Alright, now, what's the big deal with this? The big deal is I, by definition, is the square root of negative 1. And at this point in this course, we don't leave square roots in the denominator. So I'm going to get rid of this I in the denominator. Well, that's why I worked this problem up here, to show you that I'm going to get rid of this I. I want to get a real number. To do that, I'm going to multiply by the conjugate. Alright, the conjugate of 1 plus I is 1 minus I. And remember, to keep it an equivalent fraction, whatever I do to the bottom, I have to do to the top. Alright, because that would be like multiplying by 1. Now, when I multiply the numerator, I get 1 times 1 minus I, which is just 1 minus I. When I multiply the denominator, alright, now you don't have to work all this out, because remember with conjugates, that O and that I are always going to add out. So if I multiply the first two terms, I get 1. And when I multiply the last two terms, I get negative I squared. Alright, that's just going to be 1 minus I over 1 minus a negative 1, or 2. Alright, and if it asks for A plus BI form, split it up. So that's going to be 1/2 minus 1/2 I. Okay, and just to make sure, don't make careless mistakes here. The only time that you are not worried about that O and the I is if you're multiplying by a conjugate. So be careful with that.